Welcome back to the deep dive.
Great to be here.
So, if you're a developer and, your ambition is to go beyond just writing simple scripts, if you're really stepping into that world of large-scale professional C++Os,
Really big stuff.
exactly, then this conversation is definitely for you. Today, we're doing a deep dive into two just foundational concepts for code architecture, namespaces and enumerations.
Yeah, and these aren't shiny new tools or anything. They've been around. But understanding how senior architects use them, well, that's what separates clean, maintainable code from, frankly, a chaotic mess.
Right.
Our sources for this, they all focus on modern C++ structure, and they really hammer this one point home.
Work.
Organization is the single biggest challenge in large projects.
And these tools solve two problems.
Two very distinct but equally devastating problems if you ignore them. Namespaces stop naming collisions, and enumerations enforce strict, safe data rules.
Okay, so we're not just going to define them. We want to analyze the professional trade-offs, right? The why and the when of using them. Let's dig into the insights we've pulled, focusing on what's crucial for truly scalable software.
Sounds good.
All right, let's unpack the first one, namespaces. When a professional code base starts to grow, or, when you start pulling in big external libraries,
Which every major project does.
every single one, the biggest headache, a lot of the time, isn't even the logic. It's just names. So what is the core problem that namespaces are built to solve, and why is it so serious?
It's the conflict. It's all about ambiguity, what we call the name collision problem.
Okay.
So imagine two different parts of your code. Let's say it's your own rendering library and some third-party physics engine you bought,
Mm-hmm.
and they both define something with a really common name.
Like vector or status.
Vector is the classic example. The compiler sees red. It has no idea which vector you mean. Now, in a tiny project, you just, rename one.
Yeah, easy fix.
But in a code base with tens of thousands of files, this can cause these subtle linker errors that are an absolute nightmare to trace. So namespaces just provide these isolated regions for names, guaranteeing they're unique.
So it's like putting a label on a box.
That's a perfect analogy. Formally, a namespace is a declarative region that provides a distinct scope. So if the physics library defines vector inside the physics namespace,
Physics.vector.
right, and your renderer defines its vector inside the renderer namespace, then the compiler sees physics.vector and renderer.vector. No conflict. Problem solved.
And most developers, even beginners, have seen this with the most famous namespace of all, std.
Oh.
We use it constantly, std.count, std.string. But the real professional insight here is that we have to go beyond that. We have to create our own.
Absolutely. Custom namespaces are essential. You organize your code logically. You might have, say, app.database layer, app.userinterface, app.network.
So the structure of your code mirrors the application's actual architecture.
Exactly. And they can get pretty long, reflecting a really detailed hierarchy.
Okay, so that brings us to the tricky part. Accessing the stuff inside those namespaces, especially the long ones. Our source material laid out 3 ways to do it, but it seems to strongly prefer 2 over the third.
Very strongly.
Let's start with the best practices then. The ones that balance precision and readability.
Okay, so the first one, the absolute gold standard for precision, is what's called the fully qualified name.
And that's using the 2 colons,
Yep, the namespace resolution operator.
Yeah.
You just write out the full path. app.physics.calculations.calculate force.
I get the appeal. I mean, it's completely unambiguous. You look at that line and you know exactly where that function lives.
Right.
But here's my pushback. When your namespaces get nested 4 or 5 levels deep, writing that full path out over and over again, that seems so verbose. Isn't that a huge hit on readability in its own way?
That is a critical trade-off. You're right. And the sources confirm it's a constant debate among developers. The verbosity is real.
So what's the rule?
The rule of thumb, especially, and this is key when you're in a header file, is you must prioritize safety over convenience.
Always in headers. Why?
Because if you don't, you risk polluting the global scope of any other code that includes your header. You could accidentally cause name collisions in some other part of the project miles away from your code. Using the fully qualified name in a header prevents that entirely.
Okay, that clarifies it completely. Safety first in headers. So what about that second best practice? The one that's better for, say, an implementation file, a .cpp file.
That would be the using declaration. This is much more surgical. Instead of importing everything, you explicitly declare only the specific names you need for that file.
Can you give an example?
Sure. So At the top of your .cpp file, you might write using app.network.socketmanager. From that point on, in that one file, you can just write socket manager instead of the full name. It cleans up the code, but you've only brought in that one specific type.
So you get the brevity, but you're still in control. You're not just opening the floodgates.
Precisely. Now, if the namespaces are really long, there's another great trick professionals use. It's called namespace aliasing.
An alias, like a nickname.
Exactly. Let's say you have this monster, app.graphicsengine.renderer.opengl backend. You can just write namespace ogle app.graphicsengine.renderer.opengl backend.
Oh, that's nice.
And now, for the rest of that file, you just use ogle.draw. It's a huge boost for readability without sacrificing any safety.
That's a great example of, architectural finesse. Okay, so let's quickly hit the third way, the one we've all been warned about, the using directive.
Ah, yes, the nuclear option.
That's what using namespace STD is, right?
That's the one. Or using namespace app.physics. It dumps everything from that namespace into your current scope.
It's convenient, I'll give it that.
It's convenient, but it's so dangerous because it instantly reintroduces the exact collision problem you were trying to solve in the first place. I once spent 3 hours debugging a weird error with a constant, only to find out some utility header had a broad using directive in it. It was awful. So the professional advice is simple. Never, ever put a using directive in a header file, period. And use it very, very sparingly inside a function in a .cpp file, only if you're absolutely sure what's in there.
Okay. So the sources are crystal clear on this. Explicit control over convenience.
Every time.
So that covers organizing the code's boundaries. Let's pivot now to managing the data inside those boundaries, which brings us to enumerations.
Right.
When we have a variable that should only hold a very specific, limited set of values, I'm thinking days of the week or the status of a job or error codes, we need to enforce that. We can't let a developer accidentally set day off week to 42.
And that is the exact job of an enumeration, or enum. It's a user-defined type made up of a set of named integral constants.
The enumerators.
The enumerators, right. The benefit is really twofold. It's about constraint, like you said, but it's also about clarity.
The source material had a great analogy for this. It said it's like a drop-down menu on a web form.
That's perfect. Yeah. If your valid job states are pending, processing, and complete, then a variable of that enum type can only hold one of those three named values. You can't put anything else in there, no accidental inputs.
And the readability gain is huge if status 2 means absolutely nothing to someone reading the code later.
Nothing.
But if status echoes job state processing is totally self-documenting. But let's get into the complexity here, the stuff professionals have to deal with. What about the old C-style enum?
Right. Okay. So historically, the classic enum in C++ had a pretty major flaw organizationally.
Which was?
Its enumerators, the names like pending or processing, they would leak into the surrounding scope. They weren't tied to the enum type itself.
Wait, what does that mean?
It means if you defined enum colors, red, blue, E, and then somewhere else you defined enum traffic light, red, yellow, green.
Oh, you get a name collision.
You get a name collision on red. The very problem we were just talking about with namespaces. The tool designed for organization was, in this case, actually causing disorganization.
So an enumeration could actually create new name conflicts. That seems like a disaster for library development.
It was a massive architectural weakness.
Oh.
And that brings us to the crucial distinction for all modern C++ development. The introduction of enum class in C++ 11. This is what professionals use now.
The scoped enumeration.
Exactly. With enum class, the enumerators, the named constants, are strictly scoped to the type itself, so you have to access them using the type name, trafficlight.red.
So they can't leak out?
They can't leak out, and they don't implicitly convert to integers. It makes them safer, it prevents the name collisions, and it really enforces this idea that they are a true distinct type.
So for anyone listening, the real takeaway isn't just use enums, it's specifically use enum class.
100%. That class keyword is there for protection and scope. It is the standard practice now, but there is a hidden detail.
Okay.
Even with enum class, under the hood, they are still fundamentally integers.
Ah, the integral value. So by default, the first name is 0, the next is 1, and so on.
Correct. But you can override this. You can manually assign any integer value you want to any of the enumerators.
And why would a developer want to do that? Why set a constant to, say, 100?
The main reason is usually for external communication or for bit flags. If you're talking to a piece of hardware or a legacy system or a web API that expects very specific status codes, you have to match those codes.
You could just declare it.
You just declare enum class status in
Mm.
error read, error write 200.
Yeah.
You dictate the exact value, and the compiler handles the rest. It gives you this amazing flexibility while keeping all the safety of the named constraint.
That makes perfect sense. So you define your variables using the safe scoped enum class type, but you still have the power to control the underlying integer when you need it for interoperability.
Exactly. It's the best of both worlds. Readability, error prevention, and low-level control when you need it.
So let's tie this all together for you, the listener, who's maybe thinking about building a really big application. We've got namespaces for structure and enumerations for data constraints. The source material couldn't have been more clear about how important these are.
Yeah, they're completely non-negotiable foundations. Understanding these tools really marks that transition from just, scripting to actually thinking like an architect.
It's all about clarity and a lack of ambiguity.
Totally. In a code base that's going to be maintained by dozens of people over years, that is paramount. These concepts ensure that when someone new joins the project, they can immediately understand the context of a piece of code just by its name and its type.
Okay, so let's synthesize this. 3 key takeaways for architectural maturity.
All right. First, namespaces. They are your primary defense against name conflicts. Use them. Use them rigorously to define logical, unique boundaries for all your code.
Second, when you access those namespaces, always default to the most explicit methods. That's the fully qualified name with the dot for maximum safety, especially in headers.
And the using declaration to bring in just specific names in your implementation files. And just stay away from broad using directives.
Right. And third,
And third, when you're defining a set of constants or states, always opt for the modern enum class, the scoped enumeration. It stops the names from leaking out and ensures your constraints don't cause new problems.
the ultimate advice we pulled from the documentation was basically to integrate these concepts into every single piece of code you write from now on.
Until it becomes second nature. Absolutely.
Just make it muscle memory.
And as you start designing your own large C++ frameworks, here's a final sort of provocative thought to chew on.
Okay.
We know organization needs deep logical boundaries. Your application might have hundreds of thousands of lines of code. So how could you use nested namespaces, names within names within names, along with those namespace aliases we talked about, to create a system where all that massive complexity is managed by exposing just a single clean facade namespace to the outside world, hiding the hundreds of implementation details underneath?
That's how real architectural beauty is made.
That's where the art is.
A great thought to end on. Thank you for sharing your source material with us for this deep dive.
My pleasure.
We'll catch you next time.